Have you ever wished for a shortcut? Not just avoiding traffic, but maybe a direct path somewhere way out there, like a portal from science fiction.
Yeah, yeah.
Well, what if we told you that, in a way, these kinds of portals actually exist, right here, relatively speaking, in our cosmic backyard?
It sounds wild, but it's true. And it's backed by some really solid NASA-funded research. Today we're diving into these extraordinary openings.
Right, how they link Earth to the sun, and crucially, how scientists, well, how they finally figured out how to find them.
Exactly. Found the signposts, so to speak.
So our mission today, to give you a kind of shortcut to understanding these real-life celestial doorways.
Let's do it.
Okay, so let's get into it, these cosmic pathways.
Yeah.
What are we actually talking about here?
Scientists call them X-points, or sometimes electron diffusion regions.
Yeah.
Basically, they're specific locations
Locations
where Earth's magnetic field connects directly to the sun's magnetic field. It forms this uninterrupted path.
uninterrupted. How far are we talking?
93 million miles long.
Wow. Okay. A direct line, magnetically speaking, right to the sun.
Precisely. And what's fascinating here is they're not static. They're not just sitting there.
Yeah.
No, data from NASA's Themis mission and the European cluster probes, too, shows they're opening and closing all the time, dozens of times each day.
Really? Dozens? Where do they usually pop up?
Typically, yeah, a few tens of thousands of kilometers away from Earth, right where our own magnetic field, our magnetosphere, meets the solar wind that's constantly flowing from the sun.
Okay. And are they all the same size?
Not at all. Most are quite small, and they don't last long. But others can be, yawning, vast, and stay open for a while.
And these have real effects on Earth, right?
Yeah.
You mentioned particles flowing through.
Oh, absolutely. When these portals are open, energetic particles from the sun stream through. They can heat up Earth's upper atmosphere,
Which causes?
which can trigger geomagnetic storms. That's the
crazy.
stuff that can mess with satellites, even power grids sometimes. And it's also what lights up the polar auroras.
Ah, the northern and southern lights. So that's the connection.
That's a big part of it, yeah.
Okay, so this sounds like a really important phenomenon to understand. But if they're invisible and unstable,
Mm.
how do you even study them?
That was the huge challenge. NASA launched a mission back in 2014, the Magnetospheric Multiscale Mission, or MMS. Its whole job was to investigate these portals.
MMS, right.
Yeah,
But the problem remained.
exactly. How do you find something that's invisible, unstable, and, well, elusive? They open and close without warning. It's like trying to find a specific soap bubble in a hurricane.
Yeah, tricky. So how did they crack it?
Well, this is where the breakthrough came from plasma physicist Jack Scudder at the University of Iowa. He essentially found the signposts.
The signposts. How?
He went back to look at older data from NASA's Polar spacecraft, which orbited Earth more than 10 years before MMS launched.
Polar. Okay.
Yeah, Polar had sensors similar to MMS, and it turns out it had actually flown through lots of these X-points back in the late 90s.
So they didn't realize it at the time, or couldn't reliably identify them.
Precisely. They didn't have a clear signature to look for. So Scudder analyzed that old polar data.
And found the
He
pattern.
found the pattern. He identified five fairly simple combinations of measurements, things involving the magnetic field and energetic particles.
Okay.
And these five measurements, when they occur together, tell scientists, you are here. You've found an X-point or an electron diffusion region.
So it's like a fingerprint.
Exactly like a fingerprint. And the crucial part, a single MMS spacecraft has the instruments to make all five of those measurements.
Ah, so one spacecraft can spot it on its own. That's a big deal.
It's a huge deal. It means MMS didn't have to spend, say, a year just learning how to find the portals, which was the original plan.
Right, trial and error.
Yeah.
Yeah.
Instead, armed with Scudder's signposts, the mission could basically get straight to work. Immediately start studying how these things operate, how magnetic reconnection happens there.
It's like getting a map before you start the treasure hunt.
That's a great way to put it. It's a scientific shortcut, really, speeding up our understanding of this fundamental process. Magnetic reconnection, it happens all over the universe.
So what does this all mean for you listening?
Wow.
It means these portals, the stuff of sci-fi, are actually real. They're here. And now we actually know how to find them.
Yeah, and that really makes you think, doesn't it? It raises the question,
Right.
what other hidden connections, what other phenomena are out there just, waiting?
Waiting for the right signpost.
The right signposts and the right questions to be asked. It just shows the universe is packed with wonders, some right under our noses, just waiting to be seen.